Okay, this problem is a percent yield problem, but it kind of turns the percent yield on its head, and it asks it in a way that you may have not worked with percent yield in the past. What it's saying is that silicon and nitrogen get together and form silicon nitride. Now, of course, we need to balance the equation. So 2 nitrogens and 3 silicon. Now that we have a balanced chemical equation, we can kind of sort out what the problem is saying about the percent yield. Well, it says that the reaction has a 95% yield, but it also says that I want to actually collect 125 grams of silicon nitride. In other words, I really want to collect that particular amount. So there's going to be some amount of silicon nitride that I could theoretically produce with a 95% yield that would get me 125 grams of silicon. So we can write down the percent yield formula. Percent yield equals actual yield divided by theoretical yield times 100. And so if I were to kind of put this information into this formula, I would get 95% equals the actual yield here is 125 grams of silicon nitride. So there's some theoretical yield that when processed through this equation, I'll get a percent yield of 95%. And so I can solve it algebraically, and what I get is 132 grams of a theoretical yield. So if you take 95% of 132 grams, you get 125 grams. And so now I've got my theoretical yield. And so what am I given now? Now this is what I'm given. I'm going to start with this information to do my conceptual plan. I'm given 132 grams theoretical yield of silicon nitride. I'm asked to figure out how much silicon is needed. So mass of silicon. And so the basic plan is to go from grams of silicon nitride to grams of silicon. And at this point, it is just a basic stoichiometry problem in a situation where there's excess of one of the reagents. So it's not even a limiting reagent problem. So I'm going to go from grams of silicon nitride to mole of silicon nitride, and using the stoichiometry, do that, use the stoichiometry of the reaction to get to moles of silicon. And then from moles of silicon, I can get to grams of silicon. So putting it together, I've got 132 grams of silicon nitride. And I can I can calculate the molar mass of silicon nitride. And that's 140.28 grams. From this balanced chemical reaction, 1 mole of silicon nitride requires 3 moles of silicon. And the molar mass of silicon from the periodic table says that 1 mole of silicon is 28.0855 grams of silicon. When I put this into my calculator, I get 79.2 grams of silicon. And that is the final answer. Okay.